Greetings, ladies and gents. I'm back again with a brand new tutorial. By the way, let me reintroduce myself. My name is Karabo Kikanankuna. And today, guys, we will be looking at mathematics paper 2. Specifically, I'll be looking at Euclidean geometry. The first question that you find in Euclidean geometry. In each and every paper that you're going to be writing, you are going to find this type of a question, which is looking for the sizes of the angles, right? This question usually throws a lot of learners off, but it's actually easy. And this video is also applicable to grade 11 because this is actually grade 11 work mixed with a bit of grade 9 work and all that. So if you're in grade 11, you can also watch this video. It's going to be very much insightful. So this question is usually 8 to 10 marks. The marks have been decreasing when you go back with the question paper. So basically it was 5 marks back then, but right now what the examiners are doing is that they're making it to be 8 to 10 marks. So you can actually score a lot of marks here, free marks, because you can actually get a total, Right, guys. So the first thing I'm gonna do to make this simple for you guys is I'm going to give you a mechanism before we can start dissecting everything. I'm going to give you a mechanism that you should use when you start answering this question, right? So the first step that you're going to do is when you approach this question, this is question 8, right? And you see that, okay, it's that type of a question when they're looking for sizes. My advice to you is to read this. I usually call this a Bible. Shout out to Mr. V. He's the one who told me that this is a Bible. So this is the Euclid Bible. So you read what they're saying, you read the whole statement, and use a highlighter. I always recommend learners to use a highlighter to highlight keywords such as parallelogram. Oh, my mouse is not highlighting. Yeah, parallelogram, cyclic quad, chord, intersect, and all these things. So what you're gonna do is when you approach this question, you're gonna take your highlighter and go to your Bible and start highlighting those key words such as cyclic quad, parallelogram, and all those kind of things. Why? Because these are gonna play a role into you finding the answer, right? Then the second step that you're gonna do after highlighting those keywords, never ever read these questions, right? Never. Before you've found anything here, please do not come here and say, oh, they're looking for R, let me find R. No. What's gonna happen is you're gonna feel like this thing is actually more difficult than it is, and it's actually easy. So you going here and saying they say I must look for R, it's actually gonna complicate a lot of things and it's gonna confuse you, making you to feel like the question paper is actually difficult while it's not, right? So my advice to learners, as always, is that you're going to read from this question 8 until there, but never come here. We do not want to know what they want. We don't care. For now, if you want to get a total in this type of question, we don't care what they are asking you, right? We're gonna take this circle, this question, and make it our baby, right? And find our angles without being asked, right? So I'm going to show you how we're gonna do this, right? So now let's dissect this thing. Very easy. So you are given this, and remember I told you, do not read those questions. Do not go to 8.1.1 and like, oh, they say I must find R. How can I find R? You are confusing yourself and you're wasting time. The question paper is going to be difficult for you, right? So now I have a mechanism, guys. I have a mechanism that I use for such things. All right. So what I'd usually do is now I'm going to teach you a mechanism that a lot of teachers know this, but it's not emphasized enough, right? So we have a formula, or let me just say a guideline called Dr. CPT. CPT. Okay, my fellow descendants. Now, this Dr. CPT, each and every letter stands for something in Euclidean geometry. Now, this mechanism, guys, is actually going to help you guys to get a total in that question, right? So now, we are going to dissect this. Please make sure that you have a pen and a book, or a pen and a paper, because I usually do not write down notes here, but I'm just explaining and just outlining a few things, right? So it would be advisable for you to write Dr. CPT wherever you are, right? Now, the question is, how are we going to use this? Now, listen to me carefully. I'm going to first tell you what each letter stands for before I explain briefly, right? So, D stands for diameter. The diameter, right? Stands for the diameter. I hope my spelling is correct, guys. I'm sorry. The last time I spelled things right was in primary, right? Your R, guys. Your R stands for the radius. Sounds familiar, ne? The radius. Circle smaller than the radius. You've heard that punchline before, right? Yeah. All right. Your C. I'm going to try and write it small. Your C stands for cyclic quadrilateral, which is cyclic quad, how most of you call it, which is cyclic. Hope my spelling is correct, guys. Quad. Okay, guys, don't mind my handwriting, but yeah, it is what it is. Yeah. P. I'm gonna try and write as small as possible. P stands for fun. Okay, let me just say P stands for parallel lines, so that I do not confuse you as yet. Parallel lines. And T stands for tangent. Okay, sounds familiar, right? If you wrote your paper one, you will know that you find tangents when you're dealing with functions and everything like that. Okay, guys, so please do note down everything that I'm doing here so that you can understand what is going on. So, guys, we have Dr. CPT right there. D stands for the diameter, R for the radius, and C for the cyclic quad, P for parallel lines, and T for tangent or tangents. It's fine. My bad. All right. So I hope everyone has noted that down, right? So now let's dissect this thing. What do I mean when I'm saying use Dr. CPT? Let's see. Guys, if you want to get a total in that section of Euclidean geometry, Dr. CPT is the best way to go. Okay. Now let's see how this Dr. CPT is going to help us, ne? Right. Now the first letter is D for diameter, right? So now let's talk about the diameter. And I'm going to be using this to refer the diameter. Sorry for the bad handwriting. The diameter. Now, guys, a diameter, most of you would know that it's a line that divides the circle into two equal halves, right? So I don't know if I'm going to find one here on my images or what. Right, here it is right there. Here is our diameter, guys. Can you see? It divides the circle into two equal halves, right? That's our diameter right there, right? And while I'm explaining the diameter, I'm also going to be using the radius. I'm going to explain them simultaneously, right? So let me draw a line and say, now let's talk about as well as the radius. Now the radius and the diameter have a relationship, guys. They have a relationship, and I'll explain that briefly just now. Right, there we go. Sorry for that. Right, now let's go back to our circle. So as you can see there, we have a diameter, right? And we have a radius, right? A diameter is a line that divides the circle into two equal halves, right? And a radius is a line drawn from the center of the circle to the circumference, right? So one thing I need you to note down is that a diameter, let's see, a diameter and a radius, they are not the same, guys, right? A radius is drawn from the center, and a diameter is that line that cuts the circle into two equal halves, right? So let's talk about the diameter, right? Now, guys, every time you see a diameter, just know that there is a possibility of you having to find angles in a semicircle. Now I'm going to explain that briefly just now. Semicircle, right? Every time you see a diameter, just know that you might have to find an angle that is in a semicircle, right? You might also have to find angles in the same segment. Okay, guys, I'm sorry, I'm taking my sweet time to write. Same segment. Okay, guys. Yeah. So now you guys, every time you see diameter, just know that there's a possibility of those two, right? There's a possibility that you might be asked to find angles in a semicircle and angles in the same segment, right? Now come to the radius. When you see a radius now, just know that somewhere along the line, if there is a chord, obviously, right? Somewhere along the line, if there is a chord and there's a radius, you might have a 90-degree angle somewhere there. You might have a 90-degree angle. 90-degree angle. If it's cutting a chord, only if it's cutting a chord and the line is drawn from the center and you definitely show that it's the radius, you will have a 90 degrees right there, right? You usually see this in your theorem 1. Yes. So guys, basically this is going to help you to actually solve that thing, because what you're going to do, you're going to look and analyze, right, and see if there's a diameter or a radius and see the properties of a diameter and the properties of a radius. Okay. Now, okay, the radius is not really complicated, even the diameter is not really complicated. So now that we know that a diameter comes with angles in a semicircle and angles in the same segment, what we can do now is go back to our question and let's check if we were given a diameter and a radius. So if in the question they did not mention anything of a diameter or a radius, please do not create your own diameter or a radius. Please, guys, this is one of the reasons why people fail this chapter. Do not create your own scenarios. Read the Bible will guide you, right? The Bible will tell you what is wrong and what is right. So let's read the Bible. In the diagram, PQRS is a cyclic quadrilateral. Chord RS is produced to TK, is a point on RS, and W is a point on a circle such that QRQW is a parallelogram. Okay, guys, from this Bible, we can see that there is nothing that has been said. There is absolutely nothing that has been said about our diameter and our radius. So for this question, these two are not applicable, right? Can we move on? I hope you copied everything down. So let's move on. All right. Now we are going to deal with C, which is now we're going to deal with what we call a cyclic quad. Right, guys. Quad means quadrilateral. Cyclic, you know what it means, right? All right, guys. A cyclic quad. When you see a cyclic quad, the first thing that should come to mind is exterior angles of a cyclic quad. It's exterior angles of a cyclic quad. Exterior angles of a cyclic quad. All right. The second thing that should come to mind is that now it's very important that you know the properties of a cyclic quad, right? So the next thing is that you're just going to know that the opposite angles of a cyclic quad are they add up to 180. They are supplementary, ne? They add up to 180, guys. Ne? What else do you know about a cyclic quad? Right? So every time you see a cyclic quad, you have to tell your brain now that, okay, now exterior angles of a cyclic quad, there's a possibility that you're going to find that, and you're also going to find opposite angles of a cyclic quad, right? That's what you should think of every time you see that, right? Now let's go back to our question and see. We were told that angle PQRS is a cyclic quad, right? Which means somewhere along the line we are going to use these two, right? Now let's move on. We're still dissecting the Dr. CPT, remember? Is now the most important one, and this one was taught, you were taught in grade 9. Bad. Parallel lines, guys, ne? So every time you see parallel lines, the first thing you should think of is fun. When you see P in that Dr. CPT, just say we are going to have fun. Ne? We are going to have fun. Right. How are we going to have fun? Let's see. They look familiar, right? I know they look familiar. They definitely look familiar. Right, guys? Okay, guys. When you see parallel lines, the first thing that you should think of is fun. Okay? Why? This is something that they created so that you guys can understand and remember these easily. Right? In grade 9, you were taught that these are called what? Corresponding angles. Okay, guys? These are corresponding angles. I can't write it in full, but it's corresponding angles. Right? And these are co-interior angles. Right? Co-interior angles. And these are called alternate angles. This is grade 9 work. These are called alternate angles, right? When we talk about corresponding angles, we are told that this angle here is equal to this angle here, right? They are equal, right? And when we talk about a co-interior, we are told that this angle here and this angle here, they must give us 180, right? When we talk about an alternate, it's usually an N, and it can also be a Z, right? This angle here must be equal to this angle here. Now, there's this one misconception that a lot of learners do, right? You are given a shape and you automatically start finding parallel lines even though they're not there. Guys, let's analyze the question. If there are no parallel lines, you have no right to use this fun thing, right? That's why they created what? Dr. CPT, so that you can see if there's parallel lines or not, right? If there is no parallel lines present in whatever you are looking for, please do not apply anything that is related to fun, please, right? A lot of learners are failing this chapter because now they are solving for scenarios that they created themselves, right? If there's no parallel lines, do not use fun. If there is no cyclic quad written in the Bible, do not use exterior angles of a cyclic quad, okay? Do not assume. The big word here is do not assume, okay? You must be told or you must be given, okay? So this is fun. I like this one because it's very easy and it's always there. Ne? They are always going to put parallel lines in this particular question, right? Just to test your grade 9 knowledge. All right. So I've explained this one. So now I'm going to explain the last one, which is tangent. Now, you know this one from paper 1, the functions. So a tangent is a line drawn externally. Let me just draw a circle, but the circle is not going to be accurate. It's a line drawn externally that touches the circle at the circumference, right? So here is it. I'm sorry my line is not straight, but that's it, right? That's just it. This is a tangent, guys, ne? Touches the circle at the circumference. Passes through the circle at the circumference, however you want to call it. Ne? This is a tangent. Alright, now let's talk about the tangent. When you see T there in Dr. CPT, it stands for tangent. Now, okay, guys, the tangent. The tangent, every time you see a tangent, the first thing you should think of is what we call a Tanko theorem. A Tanko theorem. I'm not gonna write it in full. Yeah. And then what else can you think of when you see a tangent? It depends. It really depends. Okay, yeah. But the most important thing is that when you see a tangent, just know that there is a presence of a Tanko theorem. You are in the presence of a Tanko theorem, and you must respect it, right? So, guys, that's it. That's your Dr. CPT. Now that I've dissected what Dr. CPT stands for by telling you what each letter stands for and what each and every letter means, and by going into detail, now that we know everything about Dr. CPT, how are we going to use it to answer our question? Now, the real games begin. Okay, guys, so let's go and look at our question now. We are given this, right? The first thing you're going to do is read the Bible. We read this, we read this, we read this. So what do we know about this thing? You go to the back of your answer sheet or whatever you were given, and you get there, and the first thing we're going to do is we're going to say Dr. CPT. He's the one who's going to help us solve that question. Now, what are we going to do? Remember, I told you guys, do not read these. Ignore these for now. Because what we're doing right now is that we are analyzing this thing and we're trying to solve those loopholes. Then we can answer the questions after. Actually, one thing I like about Dr. CPT is that the questions are going to answer themselves. Now, look, we are looking for this. The first thing we do, we write Dr. CPT, we read the Bible. What do we know? Do we have a diameter above? No. This does not apply. Let's scratch it out. Do we have a radius? No. Do we have a cyclic quad? Yes. Do you have parallel lines? Yes. Do we have a tangent? Let me go and check. Do we have a tangent? A line? No, we do not have a tangent. Remember, it must touch the circle at the circumference and pass through. So we do not have a tangent. So what are we dealing with here? We are only dealing with CP. Right? So C, which means we are dealing with the cyclic quad and parallel lines. So between the cyclic quad and the parallel lines, which one is easy to deal with first? I say it's the parallel lines, right? So we start here. Let's go and deal with the parallel lines first. So let's go. We can see there are parallel lines here all over this shape, right? What are we going to do? Now that we know parallel lines, every time you see them, you must think of what? Fun. So we're like, okay, there's fun. So we're going to have fun. Right. Fun. Now, let's see if I won't find any of these letters in the above question. So let's see. Fun. F. Let's look for F. Oh, I found F already. Can you see that? From Q, R, K, T. I found F, right? Perfect. Now let's see what else can I find. Can I find U? Oh, God, I just found U. There we go. Right, I just found U. Can you see? There's two of them. It's this side and it's this side. Wow. Very interesting, right? Can I find Z? Let's see. Can I find Z or not? Can I? Is the Z present here? Is the N present? No. I can't find Z because this line is not parallel. Alright. Can I? Alright. No. I cannot find my Z over there unless if you can see it but I can't see it. We'll see as the question prevails, okay? But I can't see. Yeah, I can't see Z. Alright, guys. So far, what I'm pretty sure of is that we have F and we have U. What do we know about F? That this one and this one must be equal, right? Perfect. So now let's go back to our equation. So let's start with F. Let's look at F. We have this, we have that. Remember, I'm not looking at the questions. I'm just solving for my own mysteries. Now look, I have F, I have this. So K2 and R must be equal. But do I have R or do I have K2? No, I do not have it. Right, so I'm like, okay, it's fine. Let's try out U now. U, we can find it here, right? U, we know that when we're dealing with U, we know that this plus this must give me 180 degrees. They are supplementary. Now let's go and check. I have 100 degrees, I'm sorry. And there is my other U right there. Can you see that? But it'll be wrong of me to use that. I can simply use this one. Right? Can you see? From Q to R, there's a U. From W to K, there's a U. From Q to W, there's also a U. So there's a lot of U's there, right? But I would prefer us to use the Q to R one because we have a line that is crossing over to this side here, right? So let's use Q and R, right? So what is R? Our R is going to be 80 degrees. And remember, I am not solving what I've been asked, guys. I am solving for my own mysteries. Why? Because the questions are going to confuse me. So R is equals to 80 degrees. Right, so let me write down the answers. R is equals to 80 degrees. All right. Is equals to 80 degrees. I know most of you already know the answer or the reason to this. And the reason is co-interior angles. They add up to 180, right? They add up to 180. Guys, when they mark this, it's usually 2 marks, so you'll get a mark for this and also for the reason. So please don't ever find answers and never put the reason, right? So that's how you go. Can you see how we use Dr. CPT, right? Like to find the answer? So let's go to. So now that we have 80, here, right? And now, can you see that it's possible for me to find another angle using this, right? We're still using parallel lines, guys, okay? We're still on parallel lines. We want to abuse them until they give us answers. Look, if I have R, which means I can also find K2, right? Because this F tells me that when I have F, this angle that is here is equal to the angle that is here, which is there as well. This area will be equal to the K2. So already I found angle K2. And what is angle K2? It's equals to R, right? It's equals to 80 degrees. 80 degrees. And what is the reason? It's K2, right, guys? Sorry for the handwriting. K2. And the reason is corresponding angles. I'm not going to write it in full. It's corresponding angles are equal. Yeah. So can you see that I'm not actually solving for the question, but I'm plotting in those things so that it can be much more easier for me to find answers, right? So now I have this K2. Can you see that since I have this K2, it's also possible for me to find K1, right? We were taught in grade 9 that if I have one this side, K2, and I'm looking for this one, then I can easily use what we call supplementary angles. Okay, let me see where I can put this one. I can easily say K1 plus K2 must give me 180, right? So K2, I've already found it. And what is my K2, guys? My K2 is 80. And I don't know what my K1 is, right? My K1 is X. And they must give me 180, right? What is the reason? The reason is supplementary angles add up to 180. This is something that you were taught in grade 9 or grade 10, right? Supplementary angles add up to 180, right? So how do I find my X? I take my 80 to the other side, right? And what is X now? My X would be 100 degrees. And remember, what is X? My X represents K1, meaning that K1, people from Katlehong will like this one better, is equals to 100 degrees, my bad, 100 degrees. So guys, can you see that I already found 3 angles without even reading the question. This is why Euclidean is one of the easiest and one of the most enjoyable topics you can ever find in maths paper 2. including analytical geometry, right? Cool. Now that I have this, both of them now, we were told, guys, look, parallel lines are given, so we're going to abuse them until we can plot in. Listen, we have to abuse these parallel lines until we can no longer abuse them anymore. Have you ever seen when you're eating an orange and you're squeezing it? You squeeze that liquid out until you can no longer squeeze anything. Then you throw it away. So we cannot get rid of the parallel lines until we find every point that we want to find, and then we can say, okay, now parallel lines, I'm done with you. You have helped me out. I'm done with you. Okay? Right. So I can say I'm satisfied with what the parallel lines have done for me, right? Because I have this angle, I have this angle now, and I have this angle now. So everything is much more easier now, right? It is very much more easier. Okay, guys. So now it's time to go to our cyclic quad and see how can we abuse the cyclic quad to work for us. This is going to be fun. Now, guys, the cyclic quad. I told you earlier on about the cyclic quad, that the cyclic quad, you should expect two things, and I wrote them down. I hope you've been noting down. So now we're going to use the cyclic quad, and we're going to abuse it. Remember, I told you that the only things that are applicable in this question are the cyclic quad and the parallel lines. We are done with parallel lines. Now the cyclic quad, let's go and see where the cyclic quad is. They say the cyclic quad is P, Q, R, S, right? What do we know about a cyclic quad? We know that opposite angles of a cyclic quad should give me 180, right? So guys, I have R already, and I told you that my R is going to be equals to 80, right? We found that using parallel lines, right? I don't know why I keep on using the small r. My R is 80, right? And now, guys, look at this properly. My cyclic quad is PQRS. PQRS. I have R. Which angle is opposite my R in the cyclic quad? And that is P over there, right? So what's going to happen now? We know that these two are supplementary. They must give us 180. So we're going to come here and say, okay, if R is 80, now I know that my R plus my P must give me 180, right? But now I have R and I'm looking for my P, right? So what's going to happen? We're going to transpose this 80 to the other side. Therefore, my P is equals to 100 degrees. And what is the reason behind that? Opposite angles of a cyclic quad, guys, of a cyclic. I'm sorry, my mouse is not working the way I want it to work for me today. Cyclic quad. I hope this is clear. Cyclic. Right? So can you see that we're just using our knowledge to find the angles without even answering the question? Guys, the questions are going to answer themselves, believe me. Now, I know that my P is 100. I found my P. Interesting, right? So which other angle do you think I can find using the aid of a cyclic quad, right? I told you that there's only two things applicable when you're dealing with a cyclic quad. There could be more, but for now, let's use those two things to our advantage. If we see a cyclic quad, which means there's also what we call exterior angles of a cyclic quad, right? Exterior angles of a cyclic quad. So now, can you see that right here, we have a cyclic quad which is PQRS. We were given, right? And we have an exterior angle there, right? So now that we have this exterior angle, according to mathematics, this exterior angle must be equals to something, because now we have an exterior angle to a cyclic quad, like I taught earlier on, right? So this will aid us in a way. So okay, before we go to that, right, I see something. We can also find S1 here, right? What would be S1? S1 will be our S1 will be 44 degrees, okay? We We can find our S1 using supplementary angles because these angles are in a straight line. Okay, so I would have 44 degrees over there as well. I didn't see that one, sorry. Okay guys, so let's see what else can we find. As I was telling you, we have an exterior angle out of this cyclic quad. Okay, now how is this going to help us out? This can help us find is it angle Q2 or what? This angle should be equal to that angle, guys. Okay, when we're dealing with exterior angles of a cyclic quad, I'm just gonna show you exterior angles of a cyclic quad. It's almost like the Tanko Theorem, but it's not, because now we're not dealing with a tangent, but an external line that links to the cyclic quad. Okay, look at this. If I have a circle, which is not accurate, guys, and I have my cyclic quad over there, which is not accurate as well, right? Something like this, and I have an angle here, guys. This angle will be equal to whatever. It should be equal to whatever I'm given here. Okay, guys? Okay? I hope I am not mistaken. Yeah? Hope I'm not mistaken. Now, this is what we call now the exterior angle of a cyclic quad, right? Whatever angle is here, it should also be there at the corner, right? So, let's go back to our previous example and see what is happening. Now we have 136 over there, but now here, this shape of ours has been divided, right? Now, guys, I want you to look at something, something that is very much going to be helpful to us. Can you see that this is 2 over here, right? It's an external angle to the cyclic quad of ours that we were given, which is PQRS, right? Now, what does this tell you? It tells you that our angle Q2 and our angle Q1 should actually give us this number, right? But now look, I already know that my Q1 is 100 degrees. So what is going to be my Q2, right? My Q2 should give me 36 degrees, right? That's my Q2. What is the reason? That's exterior angles of a cyclic quad. Yeah, a cyclic quad. Okay, guys, I hope it makes sense. I hope I didn't do any magic here. I hope it makes sense. I didn't do any magic. This is an exterior angle. It should give me this whole angle. There is no way I can only use Q2. It does not make sense. This whole angle should be equal to the exterior angle. So right here we have 100 degrees already. So what we are looking for is this one. What do I need to make this 136? I need 36 degrees so that this angle and this angle could be equal. All right, guys. So what else can we do? Right. Is there anything complicated? Okay, guys. We already know what Q2 is, right? And we already know what P is, right? So we can find U1. Yeah? We can find U1. Okay, now I'm no longer using the cyclic quad now. Now I'm finding regular angles. So we can find U1. How do we find U1, guys? U1 can be found by saying sum of angles in a triangle, guys. Okay, you know this one from grade 9. So guys, I want you to look at this properly. We have Q2, which is 36 degrees. We have P, right? What was our P previously? I forgot my P because I rubbed off everything, but it's whatever that was here. So my P was 100, right? This is 36. So what is U1, guys? My U1 is 44 degrees, right? Sum of angles in a triangle. Okay, I hope this makes sense. If you've been paying attention to the video, then you'll see what I just did. I took this triangle alone and found out that, okay, I have Q2, I have P, I'm only looking for U1. So to find u1, what can I do? I can easily use angles, sum of angles in a triangle to find u1. Perfect. Now that I have u1, guys, I can go back again to my old rules and find u2. How do I find u2? Guys, maths is so enjoyable. To find u2, guys, you're just going to say angles in a straight line add up to 180. These are supplementary angles. So if my u1 is 44, and then what will be my u2? Guys, come on, my u2 will be my angle u2 will be 136 degrees. I hope I'm not mistaken there. Sometimes maths just runs away. Right, now that I have my u2 as 136, what will be my u3? Guys, there's two ways of getting u3. It's either you're going to say vertically opposite angles, if you still remember them from your grade 9, or we can just say supplementary angles. At the end of the day, the answer is still going to be the same. Your u3 is so simple. It's going to be 44 degrees. 44 degrees. Let's say vertically opposite angles. Vertically opposite angles are equal. And here for u2, you know that we use supplementary angles that add up to 180. 180. Okay, guys. So after this, I've exhausted every option that I had as a maths learner. Right, now let's go and see now what's gonna happen. Let's go to our questions and see if we have solved enough. Now, 8.1.1. Did we find R, guys? Yes, we found R. Did we find P? What is R, first of all? It's 80 degrees. What is P? It's 100 degrees. We found it. 4 marks in the bag. What is angle Q? We already have Q1. We're looking for Q2. We found Q2. What is Q2? It's 36 degrees. We have 3 marks in the bag. How did we find this? We used the exterior angles of a cyclic quad, right? What is U2? U2, we found it. Where is it? 136 degrees. And that's your total. As simple as ABCD, guys. Easy, guys. I believe that everyone is going to get a total in this. I'm wishing everyone good luck in their exams, and I'll be uploading more tutorials on the following questions, probably the proving part and proving proportionality and everything like that. Yes, thank you very much for watching. Please do subscribe to the YouTube channel, guys, as I'll be dropping more insightful, more informative content in the future. And yes, I drop content on each and every subject that I know. All right. So thank you very much for tuning in. You can catch us on Facebook. It's Sci Masters. And just subscribe to our YouTube channel right here. There's a link in the description where you can join our group chat. It's for free. And I usually leave notes for learners in the description and our social media links. Please do click those if you want to follow more. Follow for more content from us and everything like that. Thank you very much, guys. Good luck on your paper 2. Thank you.